Okay, so in this last example, this function is not in standard form and it's not in factored form. In order for us to find what the x-intercepts are, we need to get it into factored form. To find the y-intercept, I can have it in any form, and to get the end behaviors, I need to know enough about the leading term to figure out what's happening on the left and right side. So I'm just going to start with the y-intercept first, because the y-intercept, all I have to do is set the x is equal to 0. So I'm going to go ahead and substitute 0 in for all the x's, and then find the value of the function. I want you to pause the video and do the same thing yourself. Okay, so I went ahead and if you look at the work, you can see I substitute 0 in for all the x's, and then I simplified and I ended up with just a y-intercept of positive 9. We're going to go ahead and let's go ahead and factor this expression now. So let's take this original expression, and what I'm seeing, I see something times x minus 3 plus something times x minus 3 minus something times x minus 3. So it sounds like we've got x minus 3 as a common factor to everything. So normally we would put common factors on the outside of our parentheses. Well, since this is an expression, I need to put that in parentheses also. So that leaves me with x squared plus 2x minus 3. So we're going to go ahead and see if that can be factored any further. This is a trinomial. This is a monomial with no GCF, so I can't do anything more with that. But this trinomial here, if I use the AC method, I have a is 1, c is negative 3. I'm looking for factors of negative 3 that add up to 2. So pause the video and factor that trinomial right now. So my factors were x minus 3 times x minus 1 times x plus 3. So the x-intercepts, again, that's when we set each of these factors equal to 0. So if I set this equal to 0, my x-intercept will be at positive 3. If I set this factor equal to 0, the x-intercept is at 1. X plus 3 equals 0 means that x is equal to negative 3. So here's my x-intercepts. So I have x-intercepts, I have my y-intercept. Let's go ahead and find our leading, figure out what our leading term is so we can get our end behaviors. Now for the leading term, I can do one of two things. I can take my original expression and go ahead and multiply that out, or I can take these factors that we just found and understand that we're going to end up doing x times x to get some answer, and then that answer times x. So I've got x times x times x. It looks like we're going to have a leading term of x to the third power. So that's my suspicion right now. I want you to go ahead and go back to the original expression right here at the top, multiply all of that out, and see what we end up with. And we're going to see if the leading term is indeed x to the third power. Okay, you can see that I've taken the original expression and have distributed, and now all I have to do is combine my like terms to get our standard form equation. Go ahead and combine your like terms if you haven't done so. So I ended up with f of x is equal to x cubed minus x squared minus 9x plus 9. It does confirm that our y-intercept is positive 9. It matches that. I do have my leading term of x to the third, which did match when I just multiplied my 3 factors here, those x's. So that matched up. So let's go ahead and figure out what's happening on the right end and left end using our end behaviors. So let's see, our end behaviors tell us that leading coefficient is 1, which means it's positive. That means the right end is rising. The degree is odd. That tells me the left end is doing the opposite, so the left end should be falling. So I am now ready to make my sketch. I want you to go ahead and make a sketch. So make sure you mark your x-intercepts and your y-intercept. You put your left and right end behavior in there. Figure out what's happening between those two ends. And then let's see how closely our two graphs match. So pause it now and try that. And you can see what I have. So does your sketch match my sketch? Did you check to see how the number of turning points should be? So the degree of our function was third power, which means my number of turning points can be 2 or less. So the number of turning points has to be less than or equal to 2. Looks like we have one turning point here, one turning point here, nothing else. So this is a very good possibility. And this is typically what your cubic functions look like. They have those 2 turns in them. All right, so we're going to do just one more thing that we did in our notes. Okay, this is page 277 that I had you tear out of your Springboard book. And on this page, the sketches have been made for us, but we don't know anything about the x and y intercepts because none of these graphs have an x-axis or a y-axis drawn in. So this is just all about trying to figure out which curve could possibly belong to which equation. So pause this video now and kind of think about how you might work these out, and then unpause and we'll kind of have that think through how we come up with these answers. Okay, so when I was looking at this, I noticed that both C and F look pretty close to each other. B and E look a lot like each other, and A and D look a lot like each other. But I also noticed that A and C both end on the right end is rising and the left end is falling. So I have the same end behaviors. So in order for me to match that up with my equations that I have up here at the top, I have to look at more than just end behaviors. I do notice over here on A, I've got 1, 2 turning points, but on C, I have 1, 2, 3, 4 turning points. So on C, I can have a degree of 5 or more, because if my degree is 5, I'm allowed to have 4 turning points or less. On A, by looking at it, I can that's 2 turning points, which means my degree is allowed to be 3 or more. So now if I look at my equations, I have 2 equations that are the 5th degree. So those 5th degree equations, they could go with either C or A. My 4th degree equations, I'm allowed to have 3 turning points or less. So that means those 2 equations right here, I cannot use those with C or F. They could still go with A. And then if I look at these 2 equations here with the 3rd degree, there's no way that those graphs can be C or F. So I'm thinking these 2 right over here that we just looked at, these 2 right here, those are the ones I should consider for A and D. So let's, what did you come up with? Which one of these do you think belongs with A, and which one of those do you think belongs with D? Go ahead and mark your paper now. Okay, so you can see that I chose that I went ahead and wrote down what my end behavior should look like based on the leading terms here. And so I chose that this first one belonged with D and the second one goes with A. So now I'm going to take a look at these 2, since we've kind of talked about those. Those 2 must go with C and F. So let's figure out which equation belongs with which of those graphs. Now go ahead and pause it and complete those. Okay, you can see that I chose that the 5th equation should go with F and the 6th equation should be C. So now let's look at B and E, that M and that W. I noticed that on both on both B and E, the end behaviors are the same. On this one, my left and right end are both falling. On E, the left and right end are both rising. That tells me that on both of those I should have an even degree. So that does match what I have left to choose from. Those both have even degrees if you look. So it's really just a matter of which one is supposed to be rising and which one's supposed to be falling. So I know that a leading coefficient that's positive tells me that my right end will rise. A leading coefficient that's negative says the right end will fall. So let's go ahead and figure out which of our 2 graphs now belong with those last 2 equations. Pause the video and complete that. And you can see my results. I have that B is negative 3x to the 4th, where E is positive 3x to the 4th. All right, so I'm hoping you have a good idea of how you do your sketches. You need to look at your end behaviors. The turning points tell you something about the number of turns. It doesn't tell you the guaranteed number, but it at least tells you what the maximum number of turns should be. And then we also had these notes right here where our x-intercepts, those are the zeros of the function. That's when we solve the function for 0. So you need to factor it first, and then you're going to solve for x. That's using your zero product property. Y-intercepts are the easy ones. You just put 0 in for the x, and you solve for y. We just talked about end behaviors. We just talked about turning points. So if you should need any additional help, please come see me in tutorials, or look for some more tutorials on YouTube. Good luck.